The electrician's ambition. Steve, the experienced electrician, kicks off his long-term investment by putting £15,000 into an account that earns 6% interest annually, compounded once a year. He's planning to let that grow for 32 years. His apprentice, Will, decides to wait 2 years before investing. He's going to use that time to save up. When he does invest, he'll be putting his money into an account that earns 8.5% interest per year, compounded monthly, and he'll let it grow for 30 years. What's the absolute minimum amount Will needs to save up during those 2 years so that when he invests, he ends up with more money than Steve after their respective investment periods? Alright guys, welcome back to another problem. Everyone loves a money problem. Not necessarily money problems, but everyone loves anything to do with money, right? So let's hope this one gets more views than the last couple, you know? Come on. Alright, anyways, enough chit chat. Right, we're going to start by writing Steve is going to have 15,000. Now I'm actually going to I'm going to derive the compound interest equations because when it comes to initially they're not so difficult. So Steve, for example, is actually quite an easy one, but when you start looking at Will's, for example, his isn't just compounded annually, his gets compounded monthly, so there's a little extra layer that you have to sort of add on, but we'll do that as we get to it, right? So as I'm sure you're all aware, compounding interest is, if it was 10%, well, I'll write it down actually. So Steve has got his 15,000, and then that gets times by 1 plus the 6%, right? So you're making 106% each year. Because if you forget the 1, then you're just going to end up with 6%. And you're just going to, what kind of investment is that? That's terrible. But obviously this would only be after year 1. And then after year 2, you'd have to times it again by 1.06. And then year 3 times 1.06 and so on and so on. So I don't need any of that. I can just put 232 to represent the 32 years that Steve's going to leave with. Was it a hedge fund? Is it a bank? Is it property? Is it Bitcoin? Who knows? For his sake, I hope it's not Bitcoin though. Right, so that's Steve. Okay, relatively straightforward and simple. Now Will's is a little bit more complicated. Simply because, well, initially we don't know his principal amount. Right, so I'm just going to denote that as X. We know that again it's going to be 1 plus. Now again, it's going to be, this one's a bit higher, so you got 8%. So you got 0.085. However, this is 0.085 over the year, but it's compounded every month, right? So you have to divide this by the 12 months in the year, raise it to, again, Will's only investing for 30 years because he needs those 2 years to save up. So we've got 30. However, because it gets compounded every month, you have to do it for 30 years times 12 months, right? So although this is smaller because you're doing it every month, so you have to divide it by the time period, it makes it a lot more here because you have to multiply it. So yeah, and I think if you look it up, this right here is the format of the equation for most compounded interest equations. You have the principal amount, I think it's denoted P, but I'm not entirely sure. And then you have 1 plus the rate of return over T times the time period times T, right? So in this situation, for Steve, the rate is 0.06. Because it's compounded once a year, the time period is just 1. So you can just have 0.06. And then N for Steve is 32 years again. Just times it by 1, so that's fine. Whereas for Will, because it's 12 months, it's 12 and 12, right? I hope that makes sense. But yeah, so like I said, I could have just plugged that out of thin air, but I figured I'd just, help you guys out if you need it. Right, anyway, so the question is, again, we're trying to find out X here, right? We need to find out how big this needs to be so that this term is greater than this term. Okay, so what I'm going to do is I'm going to write a little inequality. So I'm just going to equate these. So we've got 1 plus 0.06 to the 32 equals, actually no, not equal, sorry, is less than or greater, less than or equal to Will's term at the end of the time period. 5 over 12, 30 times 12. Okay, I hope that makes sense, because like I said, this term denotes Steve's investment after the time period. This denotes Will's, and because Will wants his to be bigger, it has to be greater than or equal to. Because like I said, I think the answer is probably going to be to about 3 or 4 decimal places. So as long as we just choose the next penny up, it should be fine. I'm going to have to use my calculator for this one, guys, because this is some pretty gnarly stuff. Right, anyway. So if I do 0.085 divided by 12, plus 1, raise that to 30 times 12, I get 12.6924. So I've got 12.6924x. Right, and just so I don't do any rounding errors, I'm just going to save this answer to the bottom. And I've got 1.06 to the 32, which is just over a half. So what I've done there, guys, is I've just moved this over here. So the equation is going to look like 15, 1, 2, 3, times by this, because I've just multiplied that together, times 0.50844 ... whatever. It's less than or equal to x. Let's times that by 15,000, and you get 7,626 and 614. So you got 7626.614 is less than or equal to x, right? And this is in pounds, right? So if Will saves up this exact amount and invests it after 2 years, he will have exactly the same as Steve, his boss. But because these young whippersnappers want to have more than their boss, you know, we need to make sure that it's greater than. So for Will to have more than Steve after the time has elapsed, X needs to be at least 7,626 pounds and 62 pence. So there you go. Now, whether Steve will pay that to Will, given he's the apprentice, that's another question. But at that point, I'm sure Will will just go out and start his own electrician company, you know. That's how usually these things go. But yeah, anyway, guys, hope you enjoyed that one. A little bit on the money side. Yeah, stay safe, invest your money, and reap the rewards.